Hello students, let's do this part 2 of section 3.3, the first derivative and graphing. We have here a function, the graph of a function. They would like to know at which value of x is the derivative of the function equal to minus 4. Okay, well, you kind of just have to look at it and make your best guesstimate. You know, there's certain places where it's obvious that it will not be 4. It will not be 4 right here. It will not be 4 at negative 4 at minus 1. Well, actually, let's see. I have to be careful here. So let me kind of make the straightest line I can. Okay, and it looks to me like the slope at minus 1 is negative 3/2. Right, just using Bry's overrun. So I'm thinking that the slope at 0 is negative 4, and you can see that. I'm going to draw a better line here. There, now it's perfect. So over 1 and down 4, the slope of that line is minus 4, and so the answer would be 0 when x is 0. Excellent. All right. At which value of x is the derivative equal to 2? Okay, it's a similar type of question. And let me get a picture of it here on my writing tablet. Okay, so we're looking for where it's going to be equal to 2. And it won't be here at negative 3, because that's where it's 0. And it won't be right there at minus 2. So the only other place where it's even positive is when x is minus 1, and you can see if I went over 1 and up 2, let me draw that better, over 1, up 2, rise over run, that's slope. So then this tangent line has a slope of 2, and so the answer is when x is minus 1. And it even draws a nice picture for us there. Find the open intervals of this graph of f where the derivative is negative. Okay, we've done questions like this before. I think it was in part 1, and all we were wanting to do now is, I don't remember how the question was stated before, but it's equivalent. I think that here they're talking about where, well, I think that this is precisely the same as it said in the last section, because it says where f prime is negative, and I believe that the only other way they could phrase that, or the way maybe they want to phrase it here in a moment, is to say where the tangent line has a negative slope. Just as they were doing in the last 2 questions. And so it would be from minus 5 to 0, right? Between here and here on the x-axis, the slope of the tangent line is negative, so that's where f prime is negative, from -5 to 0. Now I can't include either of those points because at both those points it appears to be 0, which is not negative. Right, so we will type in our answer as, oh dang, I pressed the wrong button. Sorry. We will type in our answer as from -5 to 0. What is the open intervals over which f prime is negative? Well, that would be from -3 to infinity. When x is precisely -3, the slope is 0, but anywhere to the right of -3, the slope is negative, the slope of the tangent line is negative, and it would continue on forever in that manner. Given the graph of f, identify the graph of f prime. Well, the graph of f prime here will be a straight line. Let me show you. Let's draw a picture of the situation. Okay, so here's what I'm working with. Now, over here I will sketch a graph of f prime. So this will be my graph of f prime, and this is the graph of f right here. Now, where does this graph take on a tangent line of 0, slope 0? That would be when x is 2. So when x is 2, my tangent line, well, let me say it like this. When x is 2, f prime is 0. And if, let's say x is 4, if x is 4, it sure does look like my value of f prime should be -1. So it would go through this point. And likewise, when x was 0, it appears that the slope of the tangent line when x is 0 is 1. So f prime is going through these points. It's this line. This is the graph of f prime. It says that to the left of x equals 2, we have positive values, and to the right of when x is 2, we have negative values, and x is 0, and f prime is 0 right when x is 2. So it's this one. And, oh, I wish I had said something there. They kind of put the graph of both of them on the same axes. That's useless. Don't do that. There's no reason to. It's not helpful to put them on the same. I mean, maybe, but not really. In my mind, it's not helpful. Okay, here's another one for us to get the graph of. Let me get a picture of it on my sketch pad. So they've given us f, and they want the graph of f prime. Okay. Right, so this is f of x. And over here, I will sketch f prime. And this thing has horizontal tangent lines when x is -1 and when x is 4. So then that's where f prime would be 0. It's going to go through these 2 points. To the right of when x is 4, the slope is negative. And to the left of when x is -1, the slope is negative. And everywhere in between those, the slope is positive. So it's doing something like this. Now I want you to notice here that this function f of x is called is a degree 3 function. It's a cubic function, and this one over here is a second degree function. It's just 1 degree less. All your polynomials will behave this way, and you sort of already knew that because of the derivative of x to the n being 1 degree less than where you started. So that's all we're witnessing now, is that change in that decrease in degree by just 1. So our f prime is a parabola. It opens down, goes through -1 and 4. It's this one. And see, it's not helpful. The only thing helpful in this picture is to see that when the red one is 0, the tangent line on the blue one is slope 0. Otherwise, I think it's confusing to plot them on top of each other. At which value of x is the derivative of the function equal to -1? I think you can see that that's when x is 4. It can't be when x is 5. That's way more than -1. And it can't be when x is 3, because that's when it's 0. And it can't be the other 2 points when x is 1 or 2, because that's where it's positive. So the answer is 4. Now that picture is useful, but that's not a picture of the derivative. That's a picture of the tangent line. Where's the derivative equal to -2? Well, that would be at 5. Oh, I didn't like it. Maybe I should have been more careful. Okay, I should have drawn a picture of it. I can see now that at 4, you get the -2. In fact, let's draw a picture of that. So get a picture on my sketch pad here. Okay, so yeah, I should have been more careful with doing a little bit of investigation before just jumping the gun. Your only choices are that it's one of these, right? Or did I read the whole problem wrong? No, it says -2. We want to know where the slope is -2. Okay. So at 5, it appears to be a bit more than -2, doesn't it? if I kept going here, I mean, it's nearly minus, it's clearly more than minus, it's clearly more than -2. If the slope of that, if the slope of the tangent line at 5 was going to be -2, then it would have to be the case that it intersected this point. And it doesn't. Because that's what it would mean to be -2. Here's over 1 and down 2. And it just doesn't go through that point. It's a little tricky. That one's probably -3. However, here at when x is 4, that's slope -2, and that's what slope -2 would look like. And you can see that the point that connects all those goes through 4. So, hey, maybe that's a good way to make sure that you've done it right. Is, I believe it's this one. So if I believe it's happening right there at when x is 4, then I can create a slope -2 situation where if a line is going to go through that point there, and then it's also going to go through this point here, then just 2 points to define a line, I'll connect those 2 points with a straight line. And if it happens to go through the point on the curve, on the blue curve, when x is 4, then I know that the tangent line there definitely has a slope of -2. So, oops. All right, let's do it again. Oh boy, here they don't give us any points. They just want us to declare which one has f prime being -2. So let's draw a picture. Let me get this on my sketch pad. Okay. So where is it going to be -2? Well, clearly it's got to be, clearly it's got to be to the left of this axis of symmetry. So somewhere over here. And -2 slope, I guess let me just kind of do this. This is -2. And so I'd be wondering at which x value so like at which x value would I have a tangent line that's parallel to this thing? Is it going to be right there at -4? Well, here's a -2. This is -2 slope between these 2 points. It sure does look like it happens at -4, so that's what I'm going to go with. And the statement would be that f prime of -4 equals -2. Oh, geez, that's not even what they're asking me. I need to read this more carefully. It's asking me to estimate the derivative when x is -2, not find the point where the slope is -2. Sorry. So back to the drawing board here. They want us to estimate the slope of the tangent line at that dot. That makes more sense why they have that one dot there. So at this point, what is the slope of the corresponding tangent line. Well, let's do, it appears to be less than 1. So it looks to me like it's 1/2. So if we have a run of 2, if we have a run of 2 and a rise of 1, then that is a 1/2 slope. So the question is, will the tangent line go through these 2 points? And it sure looks like it does, even though I can't draw a straight line very well. There we are. So then the statement would be that f of -2 is equal to 1/2. All right, there we are. Find the open intervals where f prime is positive. Okay, well, it's negative between -4 and 2. If it's negative between -4 and 2, it's positive outside of between -4 and 2. So that's from negative infinity. It's going to be from negative infinity all the way up to -4, but you don't include -4, and then we need to union that with, so I'll union that with 2 to infinity. And there we are. Find the open intervals where the slope of the tangent line is negative. That's from negative infinity to -2. It's everywhere to the left of -2. Find the graph of the derivative of f. This is a picture of f. You can see that this f has a horizontal tangent when x is 1. It's got a horizontal tangent when x is 1. It's negative to the right of 1, and it's positive to the left of 1. So we're going to have the graph of f prime is going to be a line with negative slope that crosses the x-axis at 1. It's this one. It crosses the x-axis at 1 because that would mean that the y value here is 0. F prime of 1 is 0. And that matches this. F prime of 1 is 0. But f prime of 2 is negative. Right? So that matches with this. This is going to have a parabola as its graph of f prime. It'll be a parabola that's opening downward. Here, I'll show you why. So here goes the graph of f. This is f of x. Where is f of x 0? Well, it appears to be 0 at about minus 2.5. So here's my, or sorry, I said that wrong. It appears to be 0 at the slope of this f appears to be 0 at minus 5, and the slope appears to be 0 when x is 0. Right? So then that means that my curve of f prime must take on the value of 0 at both minus 5 and 0. But everywhere in between those, it's positive. So it's positive in here, but it's negative on either side of that. It's the only downward facing parabola that goes through minus 5 and 0. All right, and that's all. See you in the next video.